Hello children, welcome to my channel, and today we are going to study a very important topic with respect to your upcoming board examination for class 10th physics. Chapter is electricity. The topic is potential difference, right? And we have to quickly step on the topics which will require the help of this one, that is potential difference, such as energy consumed in an electric circuit. From that topic we will arrive towards the final topic of the chapter, that is power consumed in an electric circuit, and in between we will see how heat develops in an electric circuit. So all these topics will only be understood when we understand what potential difference is, right, in terms of electric circuits. So for understanding potential difference, we would like to understand that how water flows from one point to another, right? Let us say if you have a tank A placed at a height and the tank B placed at a lesser altitude than tank A. So what is going to happen, children? If I connect a pipe from A to B, water will naturally come down from A to B. That is, water flows from higher potential. Why higher potential? Because it has height. The water in tank A has height more than the water in tank B. Therefore, water in tank A will be said to have a higher potential than the water in tank B. So as water has flown from higher potential to lower potential, right, just by a difference in their heights, similarly the charges will flow from high potential to low potential if you provide a source which can give the push to these electrons or to the charge, right? So the potential difference is nothing but an electric push. It is an electric push. It is an electric push that move charges in an electric circuit. Simplest definition. In an electric circuit. So you must focus on this word push. Like if you are trying to propel the water from the ground level to height, to certain stories, right? What is installed in your homes or in your apartments, children? Motor is there. So the work which is done by the motor here in the apartments or maybe in the domestic circles, maybe in your houses, that work done is actually the potential difference between the 2 points A and B, right? So let us say you have an electric circuit here. This is a point A, one end of the circuit, bulb is connected and circuit is open right now, and there is the another end B. So electrons are there in this passage in the circuit. We all know that electrons are there, but right now I am not making the arrows because the electrons are not moving in a particular direction. They will only move when we will provide a kind of a force. Now again I have used this word force. So which kind of force it will be? It will be a kind of electric force, or properly in higher classes you will study the word electromotive force. Electromotive force, right? Force, EMF. In short, you can just write the initials of the words. EMF is the another, you can say, synonym used for potential difference. So that push will come when you will place a motor in the circuit. Now placing a motor doesn't mean that you will place that motor which is used to pump water from the ground to the height in your homes. By placing a motor means I want to place a cell here. Now a cell has two terminals, positive and negative. You must have seen a cell in the torches at home, right? Cell has a positive and a negative terminal. With the brass cap, generally it is a positive terminal over there, and that is the other end, the negative terminal. So the positive terminal of the cell is taken as a bigger bar in the electric circuit in the symbolic form, and the negative terminal is understood as a smaller bar. And the conventional current, now I have used a word again, conventional, that is symbolic current, which should be represented in the circuit, is from positive of the cell to the negative of the cell. That is, the current flows, the conventional current flows from positive to negative. This arrow is for flows. Actually, electrons are going in the opposite direction, right? And all this happened due to not a misunderstanding, but due to the late discovery of electrons, because earlier only the positive charges were thought to move in the electric circuit. Nobody knew what is negative, what are electrons, and with the coming of the electrons, only the negative charges were understood. तो ये सब बात की बात है. तो अभी तो हमें सिर्फ समझना है कि चार्जेस को पुश करने के लिए हमें एक यहाँ पे सेल चाहिए. और अगर कई सारे सेल्स, लाइक इफ दिस इज वन सेल, आई हैव two cells, one bigger bar, one smaller bar. So this combination of two cells is known as a battery. So combination of more than one cell becomes a battery. So if I have to place a third cell, again I will rub the negative end. I will wipe out this symbol, and again I will place a positive and a smaller negative for the third cell. So this is a setup, a battery made up of how many cells? 3 cells now. So the cells or the battery is a medium of providing the potential difference or the electric push, or it is the cause for the motion of these charges, that is the electrons, because electrons are the subatomic particles which carry charges on them, right? And in the absence of this potential difference, the electrons were moving, but the motion was random, the motion was not directed. There was no net movement from a boundary, that is, let us say if this is a boundary. So if few electrons were moving in this direction from left towards right, 3 electrons I have taken. So 3 electrons were moving again in the opposite direction, cancelling out the movement, right? So the net movement was always 0 in the absence of potential difference. So the electrons are given a direction, they are pushed, and for pushing these electrons, a potential difference has to be created between the two ends of the circuit, and that is going to happen only when you are placing a battery or a cell, or providing it with some energy, right? Now what is happening over here in a cell or a battery? Cell contains, children, chemical energy, right? Cell contains chemical energy. All the energy is stored in cell in the form of chemicals. These chemicals react when the circuit is closed, and these chemicals react to release, to free the energy in the form of electric energy. So chemical energy converts into electric energy, which creates an electric field that causes electrons or charges to move. So understand how does a cell or a battery creates a potential difference which will help the electrons move, and moving electrons will cause current to flow, current, that is I, to flow, because we have learned current is charge that moves per unit time across a boundary per second. कितने कूलम्स निकले, कितने इलेक्ट्रॉन्स निकले, उन इलेक्ट्रॉन्स से कितने कूलम्स बनते हैं, तो कितने कूलम्स निकले, हर एक सेकेंड में वही क्या होता है चिल्ड्रन, करंट होता है. तो करंट कब बनेगा, व्हेन चार्जेस विल मूव इन अ डेफिनेट डायरेक्शन, in a defined direction, and it is only going to happen when you will place a motor. Motor means a cell or a battery in the electric circuit, right? And with the passage of time children, this cell or a battery will exhaust. अभी हमेशा ही थोड़ी ना पुश देती रहेगी, समय के साथ ये खर्च भी होगी और ये ख़त्म हो जाएगी. इट विल get exhausted. All the chemical energy will be consumed up, will be converted into electric energy, and that energy again, वो energy कहाँ जाएगी? That energy will be visible in the form of heat, light, or maybe sound, maybe motion, if you are turning the fans, right? अगर आपने कई सारी बैटरीज लेकर फ़ैन को चलाया तो वो दिखेगा एनर्जी कैसे, किस रूप में जाएगी, किस फॉर्म में ट्रांसफ़र होगी. दैट एनर्जी विल बी ट्रांसफॉर्म इनटू motion of the blades. Then further that energy will be transformed further into wind energy. So transformation hota rahega. Energy will never be lost, will never be created, right? So यहाँ पर I should we should close this topic by understanding the empirical implication, that is the empirical formula for potential difference. Potential difference is denoted by the symbol V, that is voltage. Voltage is actually the potential difference, right? And the word voltage comes from the famous Italian physicist, that is Alessandro Volta. He did a lot of work on electric current, electric circuits, electricity basically. So voltage is equal to work done, that is, अब वर्क क्यों होगा, क्योंकि इलेक्ट्रॉन्स को पुश करना पड़ेगा करंट को फ्लो करवाने के लिए, ताकि सर्किट से करंट फ्लो हो. तो वर्क शुड बी डन, एनर्जी मस्ट बी ट्रांसफर्ड फॉर डूइंग दिस वर्क इन नाउ दिस अपॉन मीन्स इन मूविंग अ यूनिट पॉजिटिव चार्ज और अ यूनिट नेगेटिव चार्ज और अ यूनिट चार्ज फ्रॉम अ पॉइंट ए टू अ पॉइंट बी in an electric circuit, right? Now let us do some maths here. So now the question arrives, define 1 volt. Define 1 volt. Now what is 1 volt, children? Let me tell you children, volt is actually the unit to measure voltage, that is potential difference. Volt is unit for measuring potential difference, PD dot. How much voltage, how much potential difference is there between the ends of the circuit? That gives you the number of volts. So define 1 volt. If you go by the definition here, which I have boxed in, which I am boxing in right now, so in place of voltage I can write 1 volt, and 1 will only come as the quotient of the fraction when the numerator will be 1 joule, that is work done is 1 joule, energy spent is 1 joule, in transferring, in moving 1 coulomb of charge from a point A, or a unit coulomb of charge from a point A to a point B in an electric circuit, right? So again I am rewiring my definition once again. So 1 volt is the potential difference applied across, 1 volt is the potential difference applied across an electric circuit. An electric circuit, this is the circuit with the switch closed. This is a cell. I have taken these 2 points very, very far apart. That should not be the case. So this is the bulb, this is the switch, right? Now I am keeping these 2 points closer than before. So see, let me rub it completely. So here I am keeping them close to each other. Now if I place a cell with one positive, one negative. This cell will be said to have a potential difference of 1 volt, or it has the capacity to create this cell, right, this cell, with one bigger terminal as positive terminal and one with the smaller terminal as the negative terminal. So this cell has the capacity to create a potential difference of 1 volt if 1 joule of energy is being spent in moving a unit positive charge from point A to point B in an electric circuit, and this is an electric circuit. Again, I am speaking a definition by beginning it from a different point. When 1 joule, understand, when 1 joule of work is done, when 1 joule of work is done in moving 1 unit of charge from a point A to a point B, then we must say that the two ends of the circuit are kept between a potential difference of 1 volt, right? Then we will say that the two ends A and B are kept between a potential difference of 1 volt. So for now, it's enough to have completed this topic of potential difference, and later in the further lectures I will come up with the newer topics such as energy driven by the electric circuit in the form of heat, and finally we will come towards a topic that is very essential, right, and that is power consumed by an electrical gadget or an electrical circuit. So for now we must close our session, and you must catch up with the further videos that I will make in the near future, right. Thank you, children. Thank you for your cooperation, and you must like and subscribe to my channel if you have really seen it and understood some concepts here. Okay. Thank you, children. Have a nice day ahead.